Hey guys, this is Mrs. Lyons. This video is going to show you how to calculate the energy required to change, what did we say, 40, oh, we didn't put a mass. Let's see. Let's say we've got, so how much energy is required to raise the temperature of liquid water at 44 degrees to water vapor at 122 degrees Celsius? Let's say that we have 88 grams of water. Okay, so if you notice this, okay, in this problem, we're not going from segment A to segment D. Okay, it's really important that you look at your question and kind of map out what transformations you need to take place. Okay, so if I'm starting at 44 degrees, excuse me, that means I'm starting somewhere in here. So 44 degrees Celsius. Okay. And then I'm going to 122 degrees Celsius. So if this is 122 degrees Celsius is going to be somewhere up here. Okay, so for this calculation, we only have to calculate 1, 2, 3 segments of the graph. Okay, so we're starting, it's important to look at where we're starting. We're starting where we have just liquid. The second stage is liquid to gas. So we have boiling. And then the final segment, we have just gas. Okay, and we're going from 100 to 122 degrees Celsius. So we're heating the gas. Okay, so let's take a look at what our calculations look like. All right, when we start out, so I'm just going to label this, we'll label it C, segment C. Okay, what's happening is we just have liquid. So if I look over here at my sheet, when I'm working with liquid, I'm going to use the equation Q equals mc delta T. C is going to be 4.18 joules per gram degree Celsius. So I'm going to use Q is equal to M times C times delta T. Okay, I said we have 88 grams of water. We look at our table for the energy, the amount of joules per gram degree Celsius, 4.18. All right, and then delta T, this is where people get mixed up sometimes. So remember that delta T is equal to T final minus T initial. Okay, so and it's for just for this segment. So for this segment, we start at 44 degrees. Okay, that's our T initial. We end up here at 100 degrees. So our delta T is going to be 100 minus 44. So our delta T is going to be 56 degrees Celsius. Okay, so now let's do that calculation for that first step. All right, so Q is going to be 20,599.04 joules for that first segment. Okay, for the second segment, this is our flat spot. This is where we have boiling. We have the water that's going from liquid to gas. The temperature is not changing. So if we look at our table, we're going to use Q is equal to the mass times the heat of vaporization. And that heat of vaporization is 2,260. So let's plug this in. So segment D, we're going to use Q is equal to M times heat of vaporization. Okay, and mass is 88. Heat of vaporization we said was 2,260. So now 88 times 2,260, I get Q is equal to 198,880 joules. All right, so we've got one more leg left, and that is going to be this segment E, okay? And segment E, the temperature is changing. We just have a gas, so if we look at this, it's a gas. We're going to use this equation. Q is equal to mc delta T, where C is 2 joules per gram degree Celsius. Okay, so we're going to use Q is equal to M times C times delta T. Okay, mass is 88. We said that the specific heat is 2. And then we have to do delta T. So for this segment, delta T, we know is T final minus T initial. All right. For this segment, we start here. For this segment, the initial temperature is here, 100 degrees. And our T final is up at the top, 122 degrees. So that means our delta T is 122 minus 100, or 22 degrees Celsius. So I'm going to plug that in right here, 22 degrees Celsius. So I'm going to multiply 88 times 2 times 22. I'm going to get Q is 3,872 joules. Now, to get my final energy, my total energy, I'm going to add those three together. So 20,599.04 plus 198,880 plus 3,872 equals, I get 223,351.04. Our units are going to be joules. Okay. So you may see, oops, you can't see that. Sorry about that. So there's my final energy. Okay, so that was showing you what would happen if you started in the middle of the graph. Okay, another situation you might see is, starting down here with a solid and doing a couple of legs and ending up somewhere other than at the top. So when you're setting these problems up, it's really, really important to take a look at the temperature where things start and to relate that to the melting point, boiling point, so you start at the right place, end at the right place, and do the right calculations. All right, I hope this video was helpful. Have a wonderful rest of your day, and I will see you in class.